This is the fifth and final section of the constant acceleration chapter, section 5, which is on vertical motion under gravity. Now, all the questions we've done so far, we've had particle or objects moving in a straight line, moving this way. Yeah, and we were given the acceleration, or we needed to work out the acceleration or deceleration. What we haven't considered is particles which are moving up and down. So let's say this is the ground here, and something goes up and it drops back down. So this time, this object is moving in a vertical line this way. Now this way, there is an acceleration, but it's fixed. And this isn't an acceleration that the object has on its own, it's the acceleration of the Earth, gravity. And that value of acceleration we take to one decimal place, 9.8 meters per second squared. So anytime we have an object moving up or down under the influence of gravity, this will be the acceleration. It will never change. And notice the direction. It's going down. Gravity will never change direction. Now, if we do questions and we decide that we're going to take down as positive, so let's do a little thing here. So if I take down as positive, that means that my value of A is going to be 9.8 because it's acceleration going that way. If in the question I decide to take up as positive, then A will be negative 9.8. It's actually a deceleration acting in the other direction because it wants to make things come down. So if you throw something up, then it will decelerate. Right, what else can we see from this? Well, you see at the top point here, whatever the object is, it will stop moving for a while. At that point, V equals 0, and that's at the maximum height. So let's maybe write some things down here. So A is 9.8 meters per second squared. Now, if you do physics, you would probably use 9.81 meters per second if you're a physician. And watch out, there are some questions where it says use A equal to 10. Okay, right, and that's if we take our acceleration, or if we take this way downwards as positive. If we decide to take upwards as positive, then A will be negative 9.8. Put negative, said negative, but I wrote positive. From this little diagram here, at the maximum height, the velocity is 0. So we'll just write that down. At maximum height, so this is where the object is going to change direction. V equals 0, so that's useful if you want to find the maximum height. If I were to look at a part of this, yeah, on the way up and on the way down, at this point, the value of V going up and V going down would be the same. Okay, so this V here would equal this V here. So it's sort of symmetrical. Okay, so I'll just put down here velocities symmetrical. So you could pick any point, a certain height above the ground on the way up and on the way down. So here, for example, these velocities would be the same. So if it was 5 meters per second going up, it will be 5 meters per second going down. Now, another thing you need to be careful about is that we're using a value of A here for our acceleration, which has been rounded. It's basically been rounded to 2 significant figures. So when we give our answers, we shouldn't give them more accurately than 2 significant figures. You're actually allowed 3 significant figures, but if you give an exact answer like as a third or something, you will lose a mark. So we'll just write that down, that since the value of A we are using is rounded to two significant figures, do not give an answer more accurate than this. But you are allowed to give an answer in terms of G. Okay, so answers in terms of G are fine. But what we don't want are like answers which are surds, which are going to be exact, which ignore the fact that we're using a rounded constant here, two significant figures. So two significant figures is ideal. I think on mark schemes they will allow three significant figures, but not any more accurate than that. Don't give answers, you know, with lots and lots of decimal places or as surds. You will lose a mark. Here we have a book that's fallen off the top shelf of a bookcase. So let's say this is our bookcase here. Fantastic looking bookcase. And down here is the floor that it falls onto. We're told that the shelf is 1.4 meters above the floor. So the book drops like this. This is a distance of 1.4 meters. Since it drops, it's not been thrown down, then that will mean that the initial velocity is u. It actually starts from rest. It's not actually been thrown down. And the other thing that we have, it's always going to be here with gravity, is acceleration going down. And that is 9.8 meters per second squared. And what we need to do in part 8 is to find the time it takes to reach the floor. So SUVAT, I'm going to do an arrow like this, down, to remind me that I'm taking down as positive. So anything that goes down is positive. Anything that goes up will be negative in this case. So S is 1.4 down, below where I start. U is 0. V, I don't think we care about that, not in part A. And A is 9.8, because that goes down, so it's going to be positive. And T is what we're trying to find. So our equation that has S, U, A and T is this. S equals UT plus half AT squared. So I'll write that down. S equals UT plus half AT squared. We'll now substitute. So S is 1.4, U is 0 times by T, which we're trying to find, plus half times by 9.8 times by T squared. Now what that will give us is 1.4 equals half of 9.8 is 4.9, 4.9 T squared. So from there, the next thing that we're going to do is if we divide both sides by 4.9, so we get T squared. So T squared is 1.4 divided by 4.9, which is, this is on my calculator, 2/7. So we want to square root that to find T. We'll take the positive square root. So square root of our answer. Now, just like previously, if I wrote down root 14/7, I will lose a mark because that is exact, and we've taken A to two significant figures. Even if I wrote this as well, 0.5, 3, 4, 5, and I wrote something like that, I'll lose a mark. We can't have an answer more accurate than the numbers we started with. So we've got to round that to two significant figures. They will allow 3. So 0.53 seconds, and that's two significant figures. So 2 or 3 significant figures is fine, but not any more, not any less. Now in part B, we need to work out the speed at which the book strikes the floor. Okay, so SUVAT again. I'm still taking downwards as positive. S is 1.4, U is 0, A is 9.8, but this time I want to find V. I'm going to avoid using the T that I worked out in part A in case it's wrong, and also I don't really want to be using a rounded answer here. So if we stick with this and find the equation that has S, U, V and A, that's got to be this one. This is the only one without T again, remember. So that will give us V squared equals U squared plus 2AS. So that's V squared equals 0 squared plus 2 times 9.8 times 1.4. So V squared will equal, let's work that out, 2 times 9.8 times 1.4. That's 686 over 25, which is 27.44, which is exact there. So V is going to be the square root of that. So let's do the square root of answer. 7 root 14 over 5. Now we don't want the exact answer, remember. Two significant figures, so 5.2. So it hits the ground at 5.2 meters per second. So that'll be our answer for part B. In this case, we've got a ball that's projected vertically upwards from a point X, which is 7 meters above the ground, with speed 21 meters per second. So let's draw a little diagram. So we've got this point X. This is where the particle's projected from. And it goes up and then back down to the ground here. It's 7 meters above the ground, so this distance here is 7. And this time there's an initial velocity of 21. So here we have 21 meters per second. So can you see there's an initial velocity throwing it up, which is up, and it goes up, comes back down and hits the ground. So we've got stuff going up and down. And if we have a look at acceleration, which always goes down, that'll be 9.8 meters per second squared. So there's my diagram of what's going on. This is the path of the ball, up and back down again. And then in part A, it says the greatest height above the ground reached by the ball. Now remember, at the greatest height, the velocity is 0. So at this point here, the velocity is 0. So we want to find out how far above this point is the velocity 0, and then the greatest height above the ground reached by the ball will be this height plus the 7 it was already above the ground. So we want to find this here. Now let's write out SUVAT. Now since the ball is initially going up, I'm going to take up as positive. I want to find the distance from X to the greatest height of the ball. So actually what I'm trying to find, you see that in yellow, I'm trying to find what that distance is there, S. So I'm trying to find S. U is 21, now it's 21 up, but I'm taking up as positive. V, well at the greatest height, the velocity is 0. And A, this is negative 9.8, because I'm taking upwards as positive and acceleration is going down. So the direction is important. I've decided to take up as positive because that's the direction it's going in at the start. It's going up. If I took downwards as positive, then the signs of these would reverse. I'd still get the same answer. But let's make things easier. Since it's going up, take up as positive. So that means this is positive because it's going in the same direction. V is going to be 0. A will be negative because acceleration always points down. Whether something is going up or down, gravity always points down. So this is going to be the equation V squared equals U squared plus 2AS. V is 0, so 0 squared equals u squared, 21 squared plus 2 times negative 9.8 times s. So s is what I'm trying to find, so that's an s there, not a 5. Now 21 squared, that's 441. 2 times negative 9.8 is going to be negative 19.6 s. So we can just rearrange that to work out what s is. So that would be 441 divided by 19.6. So what do we get for s? 441 divided by 19.6. And we got 45 over 2. We get 22.5 meters. Now that is allowed because that's 3 significant figures. You would be allowed that. Or if you want to give your answer to 2 significant figures, it'd be 23. So S equals 23 meters, or you can have S equals 22.5. So you are allowed 3 significant figures, but this is just this distance here. From there to there is 22.5 meters. The greatest height, well, we need to add 7 because it's already 7 above the ground. So greatest height, and I imagine some students would forget to add the 7 on, would be the 22.5 plus 7. So we can have 29.5 meters if we're going to give our answer to 3 significant figures, or 30 meters if we're going to give our answer to 2 significant figures. So 3 significant figures, 2 significant figures, ideally 2 significant figures, since gravity, our acceleration, is given to 2 significant figures, but 3 significant figures is allowed. You won't lose a mark for that. Now in part B, it says to work out the time of flight of the ball. Okay, the phrase time of flight basically means how long is the object in the air. So let's just write that down. Time of flight equals the length of time the object, the particle, or the ball, or whatever it is we're talking about. So the particle is in the air, or airborne. That's what we need to work out. How long is it in the air? So part B, how long is this ball in the air from the time it starts there until the time it reaches the ground? So let's do SUVAT again. I am going to take upwards as positive since it goes up to start with, like this. Now leave less S to last. U is 21, so it starts off at 21. V we don't worry about. Now do not put 0 for V, because that is not the speed at which it hits the ground. That's the speed after it hits the ground. But we don't put V equals 0. We put V equals 0 up here, but not down here. This will be some other velocity it hits the ground. A, well, that goes down, so that will be negative 9.8, just like before. We want to find T, so I'll put a question mark there. Now S, how about S? Well, here S is 0. Above this point, S is positive because it's a positive displacement, because I've taken upwards as positive. Here, the displacement is still positive, but it gets smaller. At this point here, the displacement S is 0. Below this point, the displacement becomes negative because it is below where we started, and we are taking upwards as positive. So here it's 0, it goes up to a certain value. I think it goes up to 22.5 meters, doesn't it? So it increases up to 22.5. Then it decreases from 22.5 back down to 0. And then down here, the displacement is negative. So S is going to be negative 7. The ball will hit the ground when S is negative 7, because of the direction which we've taken for positive. Now you could try this question by taking downwards as positive, then S would be +7, U would be -21, and A would be positive 9.8. You will end up with the same answer, it's just all the signs get reversed. But it doesn't matter which way you do it, but make it easy for yourself. So S, U, A and T, the equation that has those four in, no V in, that's S equals UT plus half AT squared. So S is -7, U is 21, T plus half times -9.8 T squared. Okay, so that would be -7 equals 21T minus 4.9 T squared. So let's make this into a nice looking quadratic. So that would be 4.9 T squared minus 21 T minus 7 equals 0. So we can use our calculators to solve this, or we can use the quadratic equation. I think it'll probably be too tricky to try and factorize, especially with a decimal there. So T is going to equal -b, so minus -21, plus or minus b squared, so -21 squared, minus 4 times a, 4.9, times by c, which is -7, all over 2a. So that's all over 2 times by 4.9. Right, so values of t I get are 4.596509 goes on. Then the other value of t I get if I change my plus, I've just typed in the whole equation on my calculator. Scroll back and change the plus to a minus. Press the SD button. Remember, we don't want exact solutions. So 0.3 or negative 0.31079 blah. Okay, so we can ignore the negative one. Yeah, we take the positive one, but remember, answer to two significant figures. So that will be 4.6 seconds, two significant figures, maximum of 3, but nothing more than that. So the time of flight, the amount of time that the ball is in the air, is 4.6 seconds. Now, it's really useful after you've done a question, you've got an answer, think to yourself, does that sound sensible? You know, if you get a time of flight of, 200 seconds for a ball that's being thrown up in the air, that doesn't sound right. If I get a time of flight of 0.1 second, again, that doesn't sound right. But in the air for about 4 and a bit seconds sounds about right. Sounds like a sensible answer. Okay, so we've got a particle that's projected upward from a point O. So let's call this O here. At a speed of u meters per second. Okay, so let's call this u. And the greatest height, so up here, greatest height, so v equals 0, reached by the particle is 62.5 meters. Okay, so that's a distance of 62.5. And we have gravity, always have gravity going down on these types of questions. So it's 9.8 going down there. And in part A, you want to find the value of u. So let's write out SUVAT. Since it's initially going up, I'm going to take upwards as positive. Now, the maximum height is also going up above where I start, so that will be positive 62.5. U is initially up, so that's fine. So the sign of my answer should be positive. V, well, at the maximum height, V is 0, and A, that goes down, so it's got to be negative 9.8. It's the opposite direction to my arrow. And I want to find U, so I'm looking for my equation that has SU, V and A, and that's going to be V squared equals U squared plus 2AS. So V squared, 0 squared equals U squared, that's what I want to find, plus 2 times by negative 9.8 times by S, which is 62.5. So if we multiply 2 by 9.8 by 62.5, we get minus 1225. So U squared equals 1225. So U is going to equal the square root of that, which is exactly 35, and 35 is two significant figures. So that's perfect. We don't have to round it at all. So we'll just highlight that there. That is the initial velocity, 35 meters per second. And then in part B, we want to find the total time for which the particle is 50 or meters above O. Right, so on this diagram, let's imagine that this point here, this line, is 50 meters above O. It's above this point down here. What we want to do is to find the times when the particle is at 50 meters. So when S is 50 meters, so the time here and the time here, and then we find a difference between the two. So let's say, for example, at 3 seconds, it gets to this point, it goes up and comes down, and then at 5 seconds, it's at this point, so 3 and 5. So that means for 2 seconds, it's above that point. Okay, so we're going to work out these values of t when S is 50. So I'll do SUVAT. I'll take upwards as positive again. I want to find the values of t when S is 50, when the value of A would be negative 9.8, and the initial velocity is 35. So we have to use our answer from part A here. Yeah, so you want to make sure that that is correct before we use it. So S, U, A and T is going to be S equals UT plus half AT squared. So expecting two values of T, so 50 equals 35T plus half times by negative 9.8 T squared. So that will give us 50 equals 35T minus 4.9 T squared. We'll make it a nicer looking quadratic, so we'll have 4.9 T squared minus 35T plus 50 equals 0. So we'll use the quadratic equation to find our values of T. So T will be minus B, so minus B, minus 35, plus or minus the square root of B squared minus 4 times A times C, all over 2A, so 2 times by 4.9. Right, so the values of T we get, so one is 5.16861994, and the other value of T, if I just go back to my quadratic I've got here, remember you can use your calculator to solve this if you want. Change my plus to a minus, I'll get 25 minus 5 root 5 over 7, and that is 1.974237159. So this time is the time where the particle is here, and this time is where the particle is here. So the time above 50 meters is going to be the difference between these two. That's why I wrote out the full numbers, because I want to find the difference between the full numbers. Do the subtraction and write the answer. So the time above 50 meters is equal to, so I'm going to type in the full numbers. I probably only needed really to write down the numbers to 2 decimal places, because I'm only going to be given an answer to 1 decimal place. And let's just write down here what, let's call this T1, T2. So T1 minus T2 actually gives you 3.19438 and so on. 2 significant figures, 3 maximum, so I'll just go for 3.2 seconds when it's above that height of 50 meters. So again, like previously, these answers here are given to 2 significant figures because gravity that we've used is given to 2 significant figures. Okay, so here we've got a ball A, and it's falling from rest from the top of a tower, which is 63 meters high. At the same time as A begins to fall, another ball is projected vertically upwards from the bottom of the tower with speed 21 meters per second. The balls collide. Okay, so one's going up, one's going down. Find the distance where the 2 balls collide, point of collision, from the bottom of the tower. So let's draw our tower first. Maybe something like this. Here's the ground, there's my tower. Looks just like the bookcase. And we have our ball A going down. Okay, so this is going to be the path of A. That curved bit, just to show it's dropping down, maybe I'll take that out so it doesn't cause any confusion. So let's just do that. And then at the same time, B is going up. Okay, there's this point at which they collide. We want to find out what that is. We know that the height of the tower is 63 meters, like this. And we know that we have gravity going down, 9.8. A starts from rest. So here and I'll put a little a there to show that we're talking about the initial velocity of A is 0. And here, the initial velocity of B, we're told, is 21. And we'll call the distance that A has travelled its displacement SA. That'll tell us how far down it's gone. And we'll call the displacement that B has gone SB. Now what we know is that these 2 displacements add together to make 63, yeah, when they collide. So when they collide, their total displacements will be exactly 63. So for example, if their total displacements added together was only 50, they haven't quite met each other because they haven't made that total distance. If their total displacements was greater than 63, let's say 70, it means they've passed each other. The total displacement will be 63. So let's write that down. So the balls will collide when their total displacements, or the sum of their total displacements, equals 63 meters. So in other words, SA plus SB equals 63. Now this is the key to doing this question, understanding that they will meet when their total displacements make 63 the height of the tower. So what we do now is we use SUVAT to do 2 equations, and then we're going to put them together. Now with this SUVAT here, I'm putting little a's so that we know that this is going to be for what A is doing. So this is ball A here. Now since the ball is going downwards, I will take downwards as positive, and let's fill these in. So SA, well, S is what I want to write an equation for. U is 0, V I don't care about. A, well, since I'm taking downwards as positive, that will be positive 9.8. And I'll do the same with ball B. So ball B. So displacement, initial velocity, final velocity, acceleration due to gravity and time. And for this one, I suppose SB is what I want to write an equation for. Now this time I'm taking upwards as positive because ball B is projected upwards, makes it easier. The initial velocity is going to be 21, positive 21, because it's going that way. V we don't care about. A is going to be negative 9.8. But really what I need is another variable, and that's going to be T. Because there's another important piece of information. These two balls will collide at the same time. So that will allow me to link these two together because they will be equal to each other. So I'm also going to add this piece of information. Balls A and B. Balls and B, that doesn't make sense, does it? Balls A and B collide when their times are equal. So in other words, time A equals time B. Yeah, they will collide at the same time, not at the same height. Well, they will collide at the same height. But yeah, when time A equals time B, that will allow me to link these two equations together. And you'll notice when we do these types of questions where we've got two different particles, it's time that's going to link them, because the other values will be different, but when they collide, it will be at a fixed time, let's say 5 seconds. That will allow me to link the two equations. So let's get our two equations, starting with ball A. So we want an equation that has S, U, A, and T. So that's S equals UT plus half AT squared. So let's write it down here. So S equals UT plus half AT squared. So S is just SA. U is going to be 0 times by T, that's called TA, plus half times by 9.8 TA squared. So we can simplify that and we'll get SA equals 4.9 TA squared. That's our first equation. Right, let's do the same for ball B. So again, it's going to be S equals UT plus half AT squared. So here SB equals 21 times by TB plus half times negative 9.8 TB squared. So that will give SB equals 21 TB minus 4.9 TB squared. Right, so we need to link these two equations together. I could, since the value of t's are the same, make t the subject of one and substitute it to the other. What I'm actually going to do is to say, right, these values here, I can just use the same letter for both. So I'll just use t. We've said already TA equals TB when they collide. But I also know, I've said that the total displacement is 63 when they collide. So I know that this plus this equals 63. SA plus AB equals 63. And we'll replace TA and TB with just T because it's going to be the same. So SA, which is 4.9 T squared, plus SB, which would be 21T minus 4.9 t squared is equal to 63. So this is the displacement of A plus the displacement of B equals 63. That just leaves 21t equals 63, and I can work out from that t equals 3. So at t equals 3 seconds, these two balls collide. Now, we're not quite finished. I'm not sure why I thought I was finished. What we need to do from here is now to work out the distance that either this falls or this one goes up in 3 seconds. Let's use the distance that this one goes up, because we want the distance from the bottom. So let's just move that t equals 3 to one side up here. T equals 3. And let's look at ball B and see how far that is above the ground in 3 seconds. So SUVAT. So we want to find S. U is 21. Now I'm taking upwards as positive. V we don't care about. A is going to be negative 9.8 and T equals 3. So our equation that has S, U, A and T is going to be S equals UT plus half AT squared. So S will be 21 times 3 plus half times negative 9.8 times by T squared, 3 squared. So what do we get for S? Well, from my calculator, I get exactly 18.9 meters. Now you could give your answer like that if you wanted to. I'm going to do two significant figures. So that would be 19 meters. So ideally 2 significant figures. You will be allowed 3, but ideally let's write everything to 2 significant figures since gravity is given as 2. You should now be able to do exercise 9E on pages 151 to 152. You have your SUVAT equations there at the side. They are also in the formula book. So we'll do a quick recap of this section. So in these questions here, whenever we have vertical motion, it's always under the influence of gravity. And the influence of gravity, and that is an acceleration of 9.8 meters per second squared, which is to 2 significant figures, and that always goes down. Gravity never changes direction. An object may change direction, but gravity doesn't change direction. So we may have this type of thing going on where you've got something going up and something going back down like that. Gravity is going to be going down always. At this point here, at a maximum height, the velocity is 0. V equals 0. We've got symmetry. So on the way up and on the way down, these velocities are the same. So V is the same going up and down at a certain height. Also, don't make the mistake of saying that V is 0 here. So V equals 0 is not the velocity when the particle hits the ground, particle ball or whatever it is, particle hits the ground. That will be the velocity after it hits the ground, but that's got nothing to do with SUVAT. That's the fact that the ground was there and it stopped it from moving. And last couple of things to watch out for. Answers. We want to give to 2 significant figures. That's because of A. okay, since A is equal to two significant figures. And watch out, sometimes they ask you to use a different value for A, so it's like 10. So just watch out for questions where A is equal to 10 meters per second. They ask you to use that for your working. Obviously that's going to change your answer.